We look up at the night sky, we see stars. What are stars mostly made of? Hydrogen. It's the simplest, most abundant element in the universe. The Big Bang Theory tells us that hydrogen formed shortly after the universe began. But what if there are other ways? What if the Big Bang wasn't the beginning? Let's explore some mind-bending alternatives. Imagine a universe that wasn't born in a fiery explosion. No Big Bang. Instead, picture a cold, still place full of hidden potential. This is where quantum mechanics comes in. Even in stillness, there's a constant dance of energy, a fizz of particles popping in and out of existence. Could these quantum fluctuations create hydrogen? It's a wild idea, but physics tells us it's possible. In extreme conditions, energy can transform into matter. Perhaps in the early universe, quantum processes provided the spark for hydrogen to emerge. Imagine a cosmic vacuum, colder than anything we can create on Earth. This isn't just empty space, it's filled with quantum fields buzzing with energy, like a still pond hiding depths beneath. In this strange realm, particles can appear as if from nowhere. A proton here, an electron there, a consequence of the famous equation E equals mc squared, which tells us that matter and energy are two sides of the same coin. And just like that, the building blocks of hydrogen are born. But there's a catch. These particles are often born with their antimatter twins. When matter and antimatter meet, they annihilate each other in a burst of energy. So how did hydrogen survive? Perhaps there's a subtle imbalance in the universe, a slight preference for matter over antimatter, or maybe pockets of the early universe were able to isolate the newly formed hydrogen, shielding it from annihilation. Whatever the reason, the existence of hydrogen hints at a universe full of quantum surprises. The Big Bang Theory suggests that hydrogen formed everywhere at once. But what if it happened in more localized events, like cosmic fireworks scattered throughout space and time? Imagine massive clouds of gas collapsing under their own gravity. The pressure becomes immense, temperatures soar. This intense environment could be a breeding ground for hydrogen. Protons, forced together in the crucible of a collapsing cloud, could overcome their natural repulsion and fuse. This process, called nuclear fusion, releases enormous energy. It's the same process that powers our sun. These localized events could explain why hydrogen isn't perfectly distributed throughout the universe. We observe variations in its density, clumps and filaments of hydrogen gas forming the cosmic web. Perhaps these structures are remnants of ancient cosmic fireworks, long after the initial explosions. Hydrogen is constantly being consumed in stars, fueling their nuclear fires. But what if this hydrogen isn't destroyed, just recycled? Enter the cosmic recycling plant black holes. These enigmatic objects devour everything that falls into their grasp, even light itself. But black holes aren't just cosmic vacuum cleaners. They also have a way of spitting things back out. As matter falls into a black hole, it gets heated to extreme temperatures. This superheated material can be ejected in powerful jets, spewing out particles, including protons and electrons. These particles could recombine to form hydrogen once again, ready to fuel new generations of stars. This cosmic recycling process could explain how hydrogen persists over billions of years, even without a Big Bang to replenish it. It suggests a universe in constant flux, where death and rebirth are intertwined on a grand scale.